So welcome to the lecture for Pre-Calculus section 5.1. This is part 2 of the lecture. So we're going to talk about how to find the domain of g of f of x. So the main idea is that we want to find the domain of g of f of x before you simplify or before you cancel, so that you don't hide any square roots or zeros in the denominator. So we're looking for things that cause domain restrictions. So here's an example of where you would have to be careful that you restricted non-zero. X could not be 0 here. Over here you would have to find the x's that cause 0 here. Here you would have to find the x's that cause negative numbers under the radical. So we're going to practice doing some of this. So example 4 says, find and state the domain of g of f of x. So we're going to find the function g of f of x, and then we're going to look at the domain of g of f of x. So g of f of x means we're going to take the f function and we're going to put it into the g function wherever we have an x. So we've got an x here in the g function, and that's where we're going to put the f function, f of x. So this is going to equal 2 minus, then we've got the square root, and then here we're going to put in f of x and then add 3. F of x is x squared minus 4x. And then we said add 3, that's part of the g function, and that's under the radical. So in order to have real number answers, we have to have the part under the radical, which is x squared minus 4x plus 3 greater than, which means positive, or equal to 0. You can have a 0 under the square root, but you can't have a negative number. So we have to find the x values that cause this to happen, and all the other ones will not be part of the domain. So let's see if we can factor this first of all. So I've got 1 times 3, and I need 2 negatives to add to give negative 4 in the middle and to multiply to give positive 3 on the end. So I can factor this. I can say x minus 3 times x minus 1 is greater than or equal to 0. Okay, so let's see where it is equal to 0 first. So that would be at x is equal to 3, it would be equal to 0, and x is equal to 1, it would be equal to 0. So if I look at that on a number line, which is what you want to do, so the 1 would come here first, and then the 3 would come here. Okay, so we can equal 0, so essentially filled in dot at those two numbers. So we've got the interval here, negative infinity to 1. Let's put a square bracket there because it can be 1, so square bracket. And then we've got the interval, square bracket, 1 to 3. And then we've got the interval 3 to infinity. And what we're asking ourselves is, what happens to the sign of this function in those intervals where we want only positive values? So this is a good use of the sign diagram here. So I'm going to divide this up. I'm going to pick a test x, and I'm going to figure out what the sign is within those intervals and find the ones that qualify as positive. So I could pick some test numbers. So I just picked 0, 2, and 4. And I'm going to plug in those numbers into x minus 3 times x minus 1, and I'm going to figure out what my sign is. So for 0, I've got 0 minus 3, that's negative 3. 0 minus 1, that's negative 1. So that's a negative times a negative. So this is positive in this interval right there, so that qualifies. Good. Now let's test 1 to 3, and I chose 2. So I put 2 in here. I have 2 minus 3 is negative. 2 minus 1 is positive. Negative, positive. So that's negative. So that interval is not going to qualify as giving you a positive number under the radical. So we can't have any x values in that interval where our test x said we're going to get negative. Okay, so sorry, my battery died on that last thing. So we said negative between 1 and 3. So any x values in that interval are not in our domain. So let's test now the interval 3 to infinity. We're going to use 4 as our test x. So 4 minus 3 is positive. 4 minus 1 is positive. So positive times positive is positive. So the two intervals that will have elements of our domain are these two intervals here. So now I just write out my domain in interval notation. So I use my union symbol because I have a two-piece domain. Here, 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 and that is my answer. So on this example, it says find and state the domain of f of g of x. So that means g goes into f this time. Here's g, here's f. So there's two places in the f function where I'm going to have input. So I'm going to have to put g in both of those places there. All right, so let's write that out. So f of g of x, we're going to write f of g of x is equal to, so the f function is x squared minus 4x. And in these places, we're going to replace it with g of x in both of those places right there. And we're going to get the function. So g of x is this whole thing here. So I'm going to have to square that. So I've got 2 minus radical x plus 3 quantity squared minus 4 times the quantity 2 minus the square root of x plus 3. All right, and I have to simplify that. So I am going to go ahead and simplify this first, and then I'm going to go back to the unsimplified form and find the domain. But we want to know how you would actually simplify something like this. So let's go ahead and carry this out. So if I have to square a binomial, I'm going to say 2 minus the square root of x plus 3, 2 minus the square root of x plus 3, so that's squared. And I'm going to distribute over here, minus 4 times here and times here. So that's going to be negative 8 plus 4 square roots of x plus 3, doing that distributing. Okay, so if we double distribute here, I've got 2 times 2 minus, I'm going to write out the steps here because this is slightly more involved than you're used to. And then I'm going to distribute square root of x plus 3 times 2 minus the square root of x plus 3. And then the other two terms that I have are these. All right, carrying out the distributing, I got 4 minus 2 square roots of x plus 3 minus 2 square roots of x plus 3. Okay, so here I've got minus times minus, so plus. Then I've got radical x plus 3 times radical x plus 3. So since it's the same on the inside, you lift off the radical here and you'll get x plus 3. And then the rest of it. Okay, so now I'm going to identify like terms. So anything that has a root x plus 3, here's one, and here's one, are going to be like terms. So let's combine those terms with the radical in them first. So we have negative 2 of these minus 2 of these plus 4 of those. So that's negative 4 plus 4, that's 0 of those. So those are going to cancel out. So cancel, cancel, cancel. So then we're going to see we've got an x here. So x. And then we've got a 4 plus 3 is 7. 7 minus 8 is negative 1. So x minus 1. So that's what the simplified form of f of g of x is. Okay, so now we got to go back and find the domain since we were asked to do that. But this is a good time to point out that if you didn't go back to the simplified form, you would have obliterated those radicals right here and not even paid any attention to the fact that those are going to create domain restrictions. That wouldn't show up in this form right here. In this form right here, it doesn't appear that there are any domain restrictions because this is continuous. There's no chance of having zeros in the denominator here or negative numbers under the radical. So this is a good illustration of why we got to go all the way back to the beginning to figure out where your domain restrictions are. Okay, we're not dealing with denominators here, but we are dealing with radicals in this first form before we started simplifying here. So looking at this square root of 3 function, of x plus 3 function, we got to make some limitations here. Okay, so in figuring out the domain, we're going to look at this square root of x plus 3 part, because that's where we're going to have some limitations on the domain. So x plus 3, the part underneath the radical, must be positive or it could be 0. Okay, so we don't necessarily need to use the sign table in order to figure this one out. Let's just subtract 3 from both sides here. So that's x is greater than or equal to negative 3. If you look at that on the number line, we can just put negative 3. So it can be negative 3, and it can be anything greater than negative 3, so that's to the right here. So that's your interval negative 3 to positive infinity. So our domain, our answer is negative 3 to positive infinity. All right, so now we've got the function g of f of x, g of h of x. So h is going into g. So g of h of x. So h going into g. All right, so here's g. So you've got input spot right here. So h of x is going into that spot right there in the g function. And this is what h of x looks like. So we're going to have this function here that says 2 minus the square root of 2x over x plus 1 plus 3. Now let's go ahead and simplify that a little if we can. Now, is there anything reasonable to do to this? Let's turn that inside part, which is a rational function because we have x's in the denominator, into one fraction. So, and then if I want to get a common denominator, I'm going to multiply by x plus 1 over x plus 1. And I'm going to carry that process out. So I'll get 2 minus the square root of 2x over x plus 1 plus, so I'm going to distribute here, 3x plus 3 over x plus 1, which is 2 minus the square root, all right, one numerator, 2x plus 3x plus 3 over x plus 1. So now we can finally write that as 2 minus the square root of 5x plus 3 in the numerator and x plus 1 in the denominator. Okay, so that's our simplified form of g of h of x. Okay, so I cleaned that up. So that's our simplified form of g of h of x. Now if I look at this, now I'm going to work on my domain. And I'm going to look and see where I have some issues in my domain. All right, so first off, I can see that I've got a denominator here which can't be 0. So let's look at that first. So I've got x plus 1 cannot be 0, right? So that means that x plus 1, x cannot be negative 1. All right, so that's a domain restriction. And then I've also got a radical. So that means I've got the whole radical itself, 5x plus 3 over x plus 1, the square root of all that, must be either 0 or positive. Okay, now a sign diagram will come in handy for this. So let's make a sign diagram to figure out where this function is positive, all right, or 0. So let's go ahead and do this. So I already know one of my critical numbers here that I'm going to put on my number line is -1. And we're going to find another critical number by looking at the 0 here. So 5x plus 3, let's just write that here, equals 0. 5x is equal to -3. X is equal to -3/5. So these are my critical numbers here that I'm going to put on my number line, and then I'm going to do my sign analysis. Okay, so I've got those on the number line, and I do know that x cannot be -1, but we don't care if it's -3/5 because the radical is allowed to be 0. So square bracket for -3/5, smooth bracket for -1. Okay, so I'm going to put my intervals on here now. And I'm going to choose a test x within those intervals, and I'm going to figure out my sign. So I chose somewhat arbitrarily -2, -0.8, and 0 to use for my test x's. Now I'm going to go ahead and I'm going to plug those numbers into here, and I'm going to figure out my sign. So if I plug -2 into here, I get -10 plus 3, that's negative. So negative on the top. And then I plug -2 into the bottom, I got -2 plus 1, that's also negative. So negative over negative is positive. So we're positive in this interval. And we're looking for positive, so that's good. Now if I look at -0.8, and I put that into here, that would be -4 plus 3 is negative on the top. And then on the bottom, -0.8 plus 1 is positive. Positive on the bottom. Negative divided by a positive is negative. So that's a no in that interval because it's negative. We're looking for positive. And we know that because greater than 0 means positive. All right, now I plug 0 in. 5 times 0 is 0. 0 plus 3 is 3, which is positive. And then in the denominator, 0 plus 1 is also positive. So positive over positive is positive. So this is a yes. So our intervals in question are the two outside intervals. So now if we just go ahead and write this with a union symbol, the way that we would express our domain here is the domain, the domain in interval notation is -infinity to -1, round bracket, union symbol, square bracket, -3/5, comma, infinity. And this is how we would express our domain. Example 7 says, find and state the domain of h of g of x. So we're going to form h of g of x. So that means the g function is going to go into the h function. So in the h function, I've got an input spot here, and I've got an input spot here, and the g function is going to go into those two places. So 2 times, let's see, g is 2 minus the square root of x plus 3. That's your numerator. So g is going into h. This is your g, all of this going into your h. And then it also has to go here in the denominator. So g plus 1 in the denominator. So g is 2 minus the square root of x plus 3 plus 1 in the denominator. Let's simplify this a little bit. So we're going to distribute on the top here, and we're going to combine like terms on the bottom. So I'm going to get 4 minus 2 times the square root of x plus 3 for the numerator. And I'm going to get 2 plus 1 is 3. That's 3 minus the square root of x plus 3 in the denominator. And I might mention now that I don't really consider this fully reduced. It's one form of it. But what the problem is that you've got a radical here in the denominator. And in order to get that radical out of the denominator, we'd actually have to multiply by the conjugate of 3 minus radical x plus 3. A form of 1 would be 3 plus radical x plus 3 over 3 plus radical x plus 3. That would get your radical out of the denominator, but I'm not going to go there right now. I'm going to try to stick to what I'm trying to show you right now, which is now how to find the domain of this composite function. So in the numerator here, I've got a radical. In the denominator, I've also got a radical. So we can see that the part under the radical is an issue. So for the domain, we're going to have to say that x plus 3 has got to be positive or 0. So x is greater than or equal to negative 3. So on the number line, here's negative 3. Let's just put that on there for a minute. Now let's look at the denominator now. The denominator cannot be 0. So that means 3 minus the square root of x plus 3 cannot be equal to 0. All right, so let's solve for x. So I can move square root of x plus 3 to one side and 3 on the other side. And then I can get rid of the radical by squaring both sides. X plus 3 is equal to 9. X is equal to 6. So x cannot be 6, or we're going to get a 0 under the radical. So let's put that on the number line as well. Okay, except for this one's an empty circle. So let's look at the intervals. So that's negative infinity to negative 3 square bracket. And then this one is negative 3 to 6 round bracket. And this one is 6 to infinity round bracket. All right. So I can see that in this spot right here, there really is no reason to write this as two pieces because negative 3 is part of that piece. It's an okay part of it. There's no restriction there. So I can say negative infinity to 6 in union with 6 to infinity would be my domain in interval notation. So that is my domain. So there's one more to do here. We're covering all the ways this could happen as much as possible. This is h of x. H of x. We're going to use the h function twice. So here's the h function. So we have two inputs, bots here. We're going to have to put h itself, in both of these places here to create h of x. So let's do that. So we've got 2 times h itself, which is 2x over x plus 1. And then on the bottom we have h of x plus 1. H of x is 2x over x plus 1 plus 1. So this is a complex fraction. It's going to end up that this is a rational function. So we want to get it into the form of numerator over denominator, where we have not this quadruple decker looking thing, but just a double decker, one thing over one thing. So let's do a little work on this. So in the top, I'm just multiplying 2 times 2x, which is 4x, divided by x plus 1. All right, we would not want to multiply 2 to the denominator as well, because that would be multiplying by 2 over 2, which is 1, and it would reduce back to 2x over x plus 1, and then we wouldn't have multiplied it by 2. So that's what you have in the numerator. In the denominator, we've got 1 over 1. We need a common denominator of x plus 1. So we're going to have to multiply. So we get same in the denominators. So this is going to be over 2x over x plus 1 plus x plus 1 over x plus 1. All right, so let's see. This is 4x on the top over x plus 1. And then we've got 2x plus x plus 1, which is 3x plus 1, divided by x plus 1. All right, so now we can rewrite this as 4x over x plus 1 divided by 3x plus 1 over x plus 1, which is the same thing as 4x over x plus 1, flip and multiply x plus 1 over 3x plus 1. All right, so these two factors are going to cancel here, and you'll be left with h of x is equal to 4x in the numerator divided by 3x plus 1. So that's your reduced rational function. So in order to find the domain, we got to go all the way back up to before we started crossing stuff out to make sure we don't miss any zeros in the denominator on this complicated fraction here. So let's go back and look here where we've got everything set up pretty well to see where we're going to have some zeros in the denominator potentially occurring. Okay, so with this kind of a stacked up fraction, you can see that you've got denominators here in the top and the bottom fractions, but then you've also got this entire denominator here, which is the denominator of the whole big fraction. So we've got two things we got to look at. The first thing we're going to look at is this x plus 1 here in the numerator. That x plus 1 cannot be 0. So if x plus 1 cannot be equal to 0, then x cannot be equal to negative 1. So that's a domain restriction. Then the other thing that we're dealing with is this entire bottom fraction, 3x plus 1 over x plus 1, cannot be 0. 3x plus 1 over x plus 1 cannot be 0. Okay, and where that's going to occur is where that'll equal 0 is if the numerator is equal to 0. So we would say that 3x plus 1 cannot be 0, which means 3x cannot be negative 1, or x cannot be negative 1/3. So we've got two x values that are going to cause problems here with zeros in the denominator. Okay, so I put those on a number line so we can draw our domain out a little easier. So I can't be negative 1, I can't be negative 3, so I'm going to put an open circle there. But there's no restrictions on any of the other values in that range here, or over here. So it's just two numbers taken out. So this interval here is negative infinity, negative 1. Here, negative 1, negative 1/3. And here, negative 1/3, comma, infinity. So let's write that in interval notation. That's our domain with union symbols. 1 piece, 2 piece, 3 piece. And that's how you write your domain. So that pretty much wraps up what you're looking for when you determine the domain of composite functions. You identify restrictions on the domain, places where you could get zeros in the denominator or negative numbers under the square root, and you write your domain removing those parts of the domain that can't exist. Okay, so as usual, anytime you run into some problems on the homework set, you let me know. Hope you took good notes.